Okay, we're going to look at the equation x squared minus y squared equals 9. And there's two goals that I want. I want to first find dy dx. And then I want to find the derivative of dy dx. And the notation we use for that is d2y dx2. So sort of a second order derivative using the implicit derivative. Our goal is going to be to use the implicit derivative. So let's go through that process and see what happens. First thing I'm going to do is I'm going to take the derivative with respect to x of both sides. So the derivative with respect to x of x squared minus y squared equals the derivative with respect to x of 9. Okay. The derivative with respect to x of x squared minus y squared, derivative of the difference is the difference of the derivatives. Derivative with respect to x of x squared minus the derivative with respect to x of y squared equals the derivative with respect to x of 9. The derivative with respect to x of x squared is 2x minus, that's going to be a little bit of work. The derivative with respect to x of 9 is just 0. Derivative of a constant is 0. Now, how about the derivative with respect to x of y squared? How do I do that? What's my strategy going to be? The derivative with respect to x of something squared. Derivative of the outside function, 2 times the something to the first times the derivative of the inside. What's on the inside is y. Derivative of y squared is 2 times y to the first times the derivative with respect to x of y. So we get 2y. d dx of y is dy dx. So now I'm at the point where I have 2x minus 2y dy dx equals 0. And our goal is to solve for dy dx, so I can add 2y to both sides, and I can say 2x equals 2y dy dx, and then I could divide both sides by 2y. And I finish up with x divided by y equals dy dx. Which is kind of interesting. Let's go take a look at that graph and see if we can make some sense out of it. So I'm going to pull up Desmos. And I have x squared minus y squared equals 9. So I have these various points. Here's an interesting point here, right? 5, 4. Minus 16 is 9. I said the slope dy dx was x over y 5/4. So if the slope is 5/4, right? The point is 5 comma 4, so y minus y1, y minus 4 is the slope. And again, what are we saying here? We're saying the slope is x over y. So in our case here, if our point is 5/4, x over y would be 5/4. Y minus y1 is 5/4 times x minus x1 times x minus 5. This should be my tangent line, and sure enough, it is. And we could do that for other points. Certainly couldn't do that for a point where y is 0, right? If x over y is my slope, if y is 0, there's no slope, and you see that here as well. So a nice, interesting way to kind of visualize the fact that at any point, the slope of the tangent line is the x value divided by the y value. But we want to find the second derivative as well. So we know this. We know dy dx is x over y. How are we going to find the second derivative? Using the implicit derivative approach. So dy dx is x over y. I want to take the second derivative. So I'm going to take the derivative with respect to x of dy dx is going to equal the derivative with respect to x of x over y. To do this, I'm going to need to use the quotient rule. So let's do this. U is x, v is y, u prime is the derivative with respect to x of x, v prime is the derivative with respect to x of y, U prime is 1. V prime is what? V prime is dy dx. But what do I know? I know from the other page that dy dx was x over y. We've already done that. So I can make that substitution, and I can say v prime dy dx is going to be x over y. So where does that put me? d2y dx2 is u prime v. So remember our rule, right? Our rule is u over v prime. I want to make sure I have enough room here. U over v prime is u prime v minus u v prime all over v squared. So using that, what do I get? U prime v 1 times y is y, minus uv prime minus x times x over y, all divided by v squared, all divided by y squared. So now we have d2y over dx2 is y minus x squared over y, all divided by y squared. Well, at this point, what I'm going to do is I'm going to multiply the top and the bottom both by y. Multiply the top by y, multiply the bottom by y. What's that going to give me? Multiply the top by y, multiply the bottom by y. Y times y is y squared, minus y times x squared over y would just be x squared, over y squared times y, which is y cubed. Now this answer is not wrong, but it's really not finished. It's really not finished, because our original question, if you go all the way back to the beginning, our original question was x squared minus y squared equals 9. So any point on that graph that I look at, right? Any point that I would choose on this graph, it is true that x squared minus y squared equals 9. So we can simplify our answer here. What do we know? We know x squared minus y squared has to be equal to 9. If that's the case, what is y squared minus x squared? Y squared minus x squared would have to be -9, which enables us to rewrite our simplified answer to say d2y over dx2 is simply going to be what? Is simply going to be y squared minus x squared, -9 over y cubed. That's our best answer to find our second order derivative. Our second derivative using the implicit derivative approach to go ahead and find that. All right, let's try one more problem using that kind of a model. What if I have x equals y squared minus 4? And again, I want to find the second order derivative, but first I'm going to find dy dx. And then I'm going to find the second derivative, which we're going to say is d2y dx2. And let's see what that's going to be. All right, so I've got to take the derivative with respect to x of both sides. So the derivative with respect to x of x equals the derivative with respect to x of y squared minus 4. The derivative with respect to x of x is just 1. The derivative of the difference is the difference of the derivative. Derivative with respect to x of y squared minus the derivative with respect to x of 4. The derivative with respect to x of y squared, hopefully you're starting to get comfortable with this. The derivative with respect to x of y squared is the derivative with respect to x of something to the second power, which is 2 times something to the first times the derivative of the something. The something, of course, is y. So 2 times y to the first times d dx of y, which is 2y dy dx. So the derivative with respect to x of y is 2y dy dx minus the derivative with respect to x of 4 is just 0. So now I get 1 equals 2y dy dx. Divide both sides by 2y, and I have 1 over 2y equals dy dx. All the x's went away here. Now to find the second derivative, I've got to take the derivative with respect to x again of both sides. So where are we at currently? We're currently saying dy dx equals 1 over 2y. So take the derivative with respect to x of dy dx is the derivative with respect to x of 1 over 2y. So d2y dx2 is, I'm going to use the product rule, although you certainly could use the, excuse me, I'm going to use the quotient rule, although you could use the chain rule if you prefer. U is 1, v is 2y. U prime is the derivative with respect to x of 1. U prime is 0. V prime is the derivative with respect to x of 2y, which I can pull the 2 in front of the derivative operator. V prime is 2 times the derivative with respect to x of y. V prime is 2 dy dx. You remember our rule, u over v prime is u prime v minus u v prime over v square. U over v prime is u prime v 0 times 2y minus u minus 1 times 2 dy dx all over v square all over 2y squared, which is 0 minus 2 dy dx over 2 squared is 4, y squared is 4 over 4y squared. So, well, let me just go ahead and write it down that way for now, but we're going to do some simplification, of course. So upstairs I have negative 2 dy dx and downstairs I have 4y squared. Yes, we can reduce the 2 and the 4, of course. But we can also substitute in the dy dx. Remember we said at the top here that dy dx was 1 over 2y. So what I'm going to do next is I'm going to plug in 1 over 2y instead of dy dx. So my next line is d2y dx2 is negative 2 times dy dx, which is 1 over 2y, divided by 4y squared. Where does that send me? d2y dx2. So upstairs, the 2's divide out, and I get negative 1 over y, all over 4y squared. Okay, which is negative 1 over y divided by 4y squared. So we will say then d2y dx2 is negative 1 over y times 1 over 4y squared, which gives me negative 1 over 4y cubed. And that will be my second derivative for that function.